No,
I know you're not.
Okay.
All right,
I didn't mean to be like
so one more anatomical term I think we need here, and that is wavelength. So wavelength is the distance between two identical wave points. So crest to crest, right, that would be a wavelength. Trow to adjacent trow, that would be a wavelength. The symbol that we use is lambda, kind of like an upside down mu symbol, wavelength. This is used in chemistry. What is it?
Yeah.
What is it?
wavelength. The wavelength times.
Yeah. Isn't it a name in chemistry though?
Lambda.
Okay, same thing. Okay. That has a different name. All right. So wavelength is the distance between two identical wave points. It is every other node, because these are not identical nodes. Can you see? You see why they're not identical nodes? This one's like on the way up the hill, on the way down. Wavelength is inversely related to frequency, and the time that it takes for the energy to move from one identical wave part to the next. Remember, it's the energy. It's like if you were surfing on this wave, right? The time it takes to go a full wavelength is period. So remember, from simple harmonic motion, period is time for one complete cycle. So that's how it translates to waves. Okay. And so period and frequency are inversely related. If you were sitting on a dock or down at the pier and you were sort of counting the waves as they rolled in, anybody want to sing the song because I don't have a voice? Nobody? Sitting on the dock of the bay. Yeah? You got it? Is it in your head? Are you a singer?
Oh, no.
Oh, no. Oh, no. Oh, is Sarah the only one who knows that song? Look at, I can't even talk. You don't want me singing that.
I don't know the lyrics.
You know it?
I've heard it, but I don't know the lyrics.
I did sing. I don't have a problem singing. I just don't have a voice right now. Yes. Extra credit point.
What is it?
This is my second extra
Good call.
credit
Always
point
gives
for
extra credit points for the song. Wait, can you sing it again?
Very soon.
Can you do it anyway?
It's sitting on the dock of the bay, watching the ships roll by.
He's putting verses together, but it's okay. It's all right.
Okay, that's how it goes?
I'll see if I can find it on the YouTube and we'll play it. But as you're watching the waves roll in, the time between crests, or like where the wave sort of falls over, you see the white caps, right? That would be the period of the wave. The frequency would be that fraction flip. And frequency is what we're going to use more often in wave motion type calculations. So, back to kinematics. Velocity is distance over time, right? So wave speed or wave velocity, we're going to substitute distance and time from this picture. So where is there? There's a couple places where we have distance. Yep, wavelength and amplitude, right. So which one is going to be the best to use for the speed of the energy of the wave as it travels? Yes, wavelength, good. So there's your distance part, lambda. And then the time for the energy to travel one complete cycle is? Period, correct. Capital T instead of lowercase. Still physics today. All right. So distance for one cycle divided by time for one cycle. And then typically when we talk about waves, we like to talk about frequency instead of period. So what can we substitute for period? Right, the inverse is frequency. Got it? So let me write this. So period equals 1 over frequency. We already know that relationship. This is in seconds. What are the units for frequency? Hertz. So I'm gonna substitute this for period, and I get wavelength over 1 over frequency. Simplify that. And typically it's in this order, frequency times wavelength. So the final equation is velocity equals frequency times wavelength. It's because it gets so far behind. Yeah, that'll be okay. We'll see. Zoom in. It'll be fine. There is some homework. This is 12D, I think. So I'll make sure to attach it to today's lecture. There's one other wave principle, and we do have time, and we have to go, like, take a little field trip out into the hall to demonstrate it. So, the camera's not going to go on the road. I'm going to show this, though. And we're going to demonstrate this out in the hall. Oh, hold on. Sideways. Rotate. There we go. Okay, so we're going to talk about this for just a second, and then we'll go out in the hall and demonstrate it. Sorry, babies. Sorry, I know you want to go out on the field trip. No! Wrong button! Okay. So we're going, this is I'm going to use a spring, but pretend like there's a rope, and we have a couple of crests or waves that are in this rope. Remember that the rope is not going to actually move, it's the energy that moves down the rope. And there are interference patterns that are created when the two energy spots come together. When a bigger crest is created, it's called constructive interference. And when a smaller crest is created, it's called destructive interference. Okay?